Seventh grade, we've done some activities to get us ready to talk about surface area calculations. We've talked about different three-dimensional shapes and kind of what two-dimensional shapes make them up. So hopefully we're ready to break things down and find some surface areas. I should have started that over, but let's just go for it. Surface area is the total area on all the faces of a 3D object. To find it, we add all the areas of each face. So that's why you've been practicing figuring out what certain faces or what combination of faces make up each three-dimensional object. Prisms have two faces, so whether it's a triangular prism or a parallelogram prism or a trapezoid prism, they have two faces connected by rectangles. And we're going to see some examples of that, but that's just what we need to know is that prism, so if it's a trapezoid prism, it does have two trapezoids, but what's connecting both of the slanted sides? Well, it's just rectangles that are going straight back, and hopefully you can maybe imagine that a little bit. Cylinders have two circles that are connected by a rolled rectangle, and the interesting thing to know there is that one of the dimensions, the base of that rectangle is the circumference of the circle. So we'll see that in our calculations coming up. And then finally, pyramids have four identical triangles on a square base, and so we're going to see that as well. Then finally, like normal areas, meaning surface area, is measured in square units because we're just talking about covering up two-dimensional faces. Let's look at some examples. This first one says find the surface area of this triangular prism, and hopefully what I just said makes sense now. We have triangles, these two triangle faces, and they're connected by this flat rectangle on top, a rectangular face on bottom, and then another rectangle on the side. And we're going to see that they're different rectangles, but we're going to be able to calculate those pretty easy. So we said surface area is made up of all the areas. So what is this surface area made up of? This surface area is made up of two triangles, 2 times the area of the triangles, plus area of rectangle 1, plus area of rectangle 2, plus area of rectangle 3. And this might look like a really long problem, but like I said, those rectangles are going to be pretty quick and pretty easy for us to calculate. Okay, the triangles too. Let's be confident about that. So it's going to be 2 times whatever the full area of each triangle is. Well, what's the area of a triangle? We should know that it's 1/2 the base times the height. What's the base and the height here, though? Well, we can see that this looks like the perpendicular, so the base would be 4, and the height would be 3. So 1/2, 4 centimeters, or 1/2 times 4 times 3. And we'll put our units in at the end. Now the area of, let's call this guy 1, this big guy 2, and this back guy will be 3. Now, we know rectangles is just base times height. The nice thing to see is that this depth, 11 centimeters, is going to be, could be the base of each of these rectangles. So let's get to work on these. The first one is that bottom one, and it has a height of 4 centimeters, and again a depth of 11, so this would be 4 times 11. The second one is going to be, again, the base 11 times 5 centimeters. That makes the other side of this rectangle, so 5 times 11. And then finally, the last one has a height of 3 centimeters. So this 3 centimeters gets extended 11 centimeters. 3 times 11. So this is working out pretty neatly, pretty nicely so far. So now we have to do what's in parentheses first, follow the order of operations. 1/2 times 4 would be 2. 2 times 3 is 6. So each of these triangles is 6 square centimeters. And we have 2 of them, so that's why we're multiplying by 2 still. Now 4 times 11 is 44. 5 times 11 is 55. And 3 times 11 is 33. Alright, so now we just have to finish this guy off. We have 12 plus, so this is 12 plus 44. That would be 56 for us. 55 plus 33 would be 88. And that will give us a final answer of 144. And that looks right. So we need to know, well, what is the units? Well, we're talking about surface area. So it's area, so we need to know that we're using centimeters. But area is always measured in square centimeters. So it would take 144 little square centimeters, 1 centimeter by 1 centimeter squares, to cover this entire shape on all 5 sides. On all 5 sides, that's what we would need. Hopefully this breaking it down process seems to make sense to you. But yeah, that's what we got. Let's move on and see another one. The second one says, find the surface area of a soda can with a lid diameter of 2 inches and a height of 5 inches. So what a lot of people are going to do is they're going to draw a picture, especially when it's written. But even in that ones like that last one, they'll draw a picture. And they'll show the flat shapes that come together to make this. So we know we have 2 circles, and we're going to have to find the areas of those, and then we'll have to find the area of this rectangle. So what are going to be the areas of the circles? Well, the surface area total is going to be equal to 2 times the area of the circles plus the area of the rectangle. Now, what are the areas of the circles? Well, I know that area of a circle is pi times the radius squared. So we'll do 3.14 times our radius squared. Well, they said that the diameter is 2 inches, so that would mean the radius is 1 inch. 1 squared is just 1, so this is just 3.14 times 1 is just 3.14. That's easy enough. But we also, I didn't want to equal sign there. I need to say we need to add the area of the rectangle. Now we know that the height is 5 inches, so it'll go 5 inches from top to bottom. But, and I drew this too small, this should be what? What measures the distance around the circle, the lid that this has to be able to wrap? And that's the circumference. So we can say we need to do 5 times the circumference. And what's the circumference? It's the diameter times pi. So in this case it's 2 times pi, or 2 times 3.14. Hopefully you can do that mentally. That'd be 6.28 centimeters. So we need to do 2 times 3.14, and that would be the area of the circles combined, and then this rectangular portion is going to be the height, 5 inches, times 6.28. What do we get here? We get 6.28. A little repeat there. Worked out nicely since we have just a diameter of 2 inches. And then we need to add whatever 5 times 6.28 is. So let's multiply this by 5. This will give us the area of the rectangular portion, or the height of the can. 5 times 8 is 40. 5 times 2 is 10, plus 4 is 14. And 5 times 6 is 30, plus 1 is 31. 2 decimal places. So it's 6 and 28 hundredths plus 31 and 4 tenths. We can add this mentally. We'll have 37 and 68 hundredths. And again, this is inches, but a surface area has to be squared, inches squared. So we just found the surface area of the can. So we know that cans are made of pretty thin aluminum. So if they have these aluminum sheets, how much are they going to need for each can? About 38 square inches of aluminum would make each can. That might be a word problem you could see for this type of topic or concept. Finally, we're going to find the surface area of the pyramids of Giza. These should be familiar. And they gave us some measurements. They said that the base is 230 feet, and then the slanted height is 300 meters. 230 meters is the base. I'm sorry, I should have said. I told you earlier that people are going to do this sometimes. They're going to draw kind of like a folded out version. Just kind of like we did. We just kind of split it up into sections and drew them separately. But some people are going to say, well, what if you take the shape and you just unfold it? Well, what's going to be this... and we're going to pretend there's a surface area. So this doesn't really make sense. It would be if you picked out the pyramids. If you picked out the pyramids, what would be the surface area? That's what we're going to find right now. So we're just going to include that that square base at the bottom. Well, what would be the dimensions of that square at the bottom? Well, we know that the 300 meters is just the slanted height for the triangles on the sides, and it's just the 230 meters that goes around the base. So this would just be a square with side length of 230 meters. And then it'll also be the base for each of these triangles that have a height of 300 meters. So let's get to work on this. The surface area is going to be equal to 4 times the area of the triangle plus the area of a square. All right. So what's the area of the triangle? It's going to be 1/2 the base times the height. The bases are 230 meters. The height was 300 meters. I'm writing really sloppily. And we need to add the area of the square. So what's the square? It's just going to be 230 times 230, or 230 squared. Isn't that funny? 230 meters squared. So we're going to get a pretty big surface area here. 230 squared. Okay. If we're going to do the triangles first, we might do the 1/2. So it'll be 4 times the 1/2 times 230, that would be 115. 4 times 115 times 300. And we still need to do 230 squared. I'll do it up here. And I hope that you're doing this work as well. I'll just hold my placeholder so we can move straight to the tens place. 3 times 0 is 0. 3 times 3 is 9. 3 times 2 is 6. Now I need 2 placeholder zeros because we're going to go to the hundreds place. 2 times 0 is 0. 2 times 3 is 6. 2 times 2 is 4. We'll add all this up. What do we get? 0. That was a bad looking 0 right there. 9. 6 and 6 is 12. So 52,900. Wow. Maybe we shouldn't have included that base. I have a feeling it's going to be pretty big either way. Alright, we can do 4 times 115. 115 times 300, we could just multiply this times 3. 3 times 15 is 45. 3 times 100 is 3. And then we'll add our 2 zeros. So we have 4 times that plus 52,900. Ah. Again, let's just do this mentally. 4 times 0 is 0. 4 times 0 is 0. 4 times 5 is 20. Carry 2. 4 times 4 is 16. Plus the 2 is 18. Carry a 1. 4 times 3 is 12. Plus 1 is 13. So 138,000 plus 52,900. And it's important to know, what is this unit going to be when we finally get this answer of 190,900? Yeah, 190,900, not just meters, but square meters. Okay, sorry, that one took a while, but hopefully the process made sense, even if including the base didn't, because that surface area is unseen. That face is unseen, but that's okay. All right, I'm going to leave you with some problems on your own. You can feel free. This first one I'm going to ask you to definitely draw it out. It says a rectangular prism has a base of 16 meters, a height of 3 meters, and a depth, or this prism goes back 10 meters. Draw it and then find its surface area. And then the second one, this is the same looking shape, a triangular prism from a different different homework video I had you guys watch, but I'm going to have you find the surface area instead of the volume this time. So this front face is a triangle with a base of 12 feet and a height of 4 feet, and this time you do need to know that the other two sides are 2 feet. So think about all the shapes that make up those faces and find the surface areas. I'll see you tomorrow.